Happy day, everybody. This is Orekoya Olusegun, Physics Mathematics Fundamentals on YouTube. We want to continue our last tutorial on factor theorem and remainder theorem. Please, I would rather prefer that you go to my other video to update on the introduction to polynomial function, the factors, the quotient, the remainder, the divisor, dividend, the remainder, and the factor theorem. So now we want to solve this problem. Look at this problem. Given that x plus 1 and x minus 2 are factors of polynomial x cubed plus px squared plus qx minus 6, find p and q. Then question B says factorize the expression completely. Factorize means you get the factors of this. Now this is what we want to do now. Look at the procedure. We are given x cubed plus px squared plus qx minus 6. We want to find the value of p and q, and the factors that are given for this polynomial are these two factors that we have there. These two factors, x plus 1 and x minus 2. So what I'm going to do now, we are given these two factors, x plus 1 and then x minus 2. Those are the factors given. That means according to the remainder theorem, when we set each of these to 0 and look for the value for x, we substitute here. If our remainder must be equal to 0, and for this one too, if this one is a factor, we set this one to 0 and we look for the function of x. When we make x or the formula, when we put it there, our remainder should be 0. What am I trying to say is this? Let me start with x plus 1. So we set this x plus 1, we set it to 0. So we make x or the formula. When you carry plus 1 to that side, become minus 1. So we are going to look for when x is minus 1 here. So you now say minus 1 raised to power 3 plus p bracket minus 1 square plus q bracket minus 1 minus 6 must give us a remainder 0. So like this one, it has a odd power, so the sign here will remain negative. So here now, minus 1 raised to power 3 is same thing as minus 1. This one has even power, so whatever you are going to have here will be positive. That's plus. So 1 times p give me p, then minus times plus give me minus q minus 6 is equal to 0. Then minus 1 minus 6, that will give us minus 7. When we carry minus 7 to that side, give us plus 7. So we have p minus q minus 1 minus 6, that's minus 7. When we carry to that side, give us plus 7. So call this one equation 1. Then we move down to the second factor, we set it to 0. So you write x minus 2 is equal to 0. We make x or the formula. By carrying minus to the other side, become plus 2. So we look for the function 2 by substituting 2 here. So we have 2 raised to power 3 plus p bracket 2 raised to power 2 plus q. We put 2. So bracket 2 minus 6. Everything must be equal to 0. We are following what is called remainder theorem. So 2 raised to power 3 is 8. The meaning of 2 raised to power 3 means 2 times 2 times 2. 2 multiply itself in 3 places. 2 raised to power 2 means 2 multiply itself in 2 places. 2 times 2, that's 4. That gives us 4 times p, that's 4p. Then 2q plus 2q minus 6 is equal to 0. 8 minus 6 give us 2. When we carry the 2 to that side, give us minus 2. So I have 4p plus 2q is equal to minus 2. Since I know that I can divide through by 2 to simplify this equation, if I divide through by 2, 2 in 4 will give me 2p, plus 2 in 2 will give me 1, so this will be q. Then minus 2 divided by 2 give me minus 1. So we call this one equation 2. So we are going to work on these two equations to get the value of p and q. Now I will write the two equations separately. So the first equation that we have is p minus q is equal to 7, and the second equation that we have is 2p plus q is equal to minus 1. By addition method, adding these two together, 2p plus p will give me 3p. So 2p plus p give me 3p. Minus q plus q, that's 0. 7 take away 1, that's 6. So to get p, divide both sides by this coefficient of p. So this will be p is equal to 2. So I've gotten my p to be 2. So to get a q, you can substitute these two inside either of these two equations. So I want to substitute to the first equation. So my p is 2. You put 2 there. 2 minus q is equal to 7. So I can carry putting 2 here. 2 minus q is equal to 7. I want to make my unknown to be positive by carrying it here to become q. Then I carry plus 7 to that side, become minus 7. That's 2 minus 7. And 2 minus 7 give me minus 5 is equal to q. So I've gotten the value for p and q. My p is now 2. Our p that we have gotten now is now 2, and the q that we got is now minus 5. So that now gives us the idea of the makeup of the original polynomial functions that was given to us, and that is it here. So we substitute these values here. So I have s cubed. My p is 2, so I put 2 here. That will be 2 plus 2p plus 2s squared. My q is minus, so when I put it here, that's minus 5x minus 6. So this is the polynomial, and the question says we should factorize this polynomial completely. Now when we want to factorize, we look at the highest power of the unknown variable. If you look at here, the variable, the power here is 1, the power here is 2, the power here is 3. So the number of the degree of the power, or the degree of the power, determine the number of factors we are going to have. So we are going to have 2 factors, and the factors normally have this shape: x plus or minus a times s plus or minus b times s plus or minus c. Now this particular constant here, their product must be equal to the last term here, that's constant term. So that means a, b, c multiplying must give us a product of 6. So for us to get the value for a, b, c, we are going to look for the factors of 6. Factors of 6 include 6 times 1, include 2 times 3. So these are the factors of 6. So what we are going to be doing is that we are going to be testing each of these factors on this a, b, c. So I want to pick this particular first factor, that is s plus or minus a. I want to start with a factor of 1. So that means my a is 1. So I will now write x plus or minus 1. So we are going to set this to 0 and test whether it will give us 0 according to remainder theorem. Now let me pick one of these factors, because the factor that I have here, the meaning of it, I'm having two things entirely. It means s plus 1, and it also means x minus 1. That's the meaning of what I summarize here. So let me pick s plus 1 and set it to 0. So I have s plus 1 is equal to 0. So taking this here, x is equal to minus 1. So we are going to test minus 1 here. If it gives us 0, that means s plus 1 is a factor. Let's try this now. We have minus 1 raised to power 3 plus 2 times bracket minus 1 raised to power 2 minus 5 bracket minus 1 minus 6. Minus 1 raised to power 3 give us minus 1. This one give us plus 2. This one give us plus 6 minus 6. If you look at this now, this will never give us 0. This is give us 0. Let me try this again. When I put minus 1 here, I have minus 1 raised to power 3 plus 2 bracket minus 1 square minus 5 bracket minus 1 minus 6. So this one give us minus 1. This one give us 1. 1 times 2, that's plus 2. This give us plus 5 times 1, that's 5 minus 6. If you look at this very well, 2 plus 5, that give us plus 7. Minus 1 minus 6 give us minus 7. So minus 7 plus 7 give us 0. That means this first one that we tested is a factor, one of the factor of this particular polynomial function. We can equally test for, since I already tested for this and it's a factor, that means this can never be a factor, so I don't need to waste time. So you can equally go to these two and test for this b and go through the process. But in order not to waste time, because it will take a longer time, since I have gotten one of the factor and one of the factor is s plus 1, I will use what is called long division method to get the other two factors, the remaining factors. So what I'm going to do is that I will take this divisor outside here, then I take this s cubed plus 2s squared minus 5x minus 6. Now we use this one and we use this one to divide this. So I'm going to have s cubed divided by x. That will give me s squared. So this s squared, write it up there. They use these two to multiply. X times s squared give me s cubed, plus 1 times s squared give me plus s squared. So the next thing is to subtract. When you subtract here, this minus will affect everything inside this bracket, I mean the sign. So this one, I had it up, this will give me 0. So here now it's going to be 2s squared minus s squared. That will give us s squared. The moment you have done your subtraction, bring the next term down, that is minus 5x. Start the process again. Use this x to divide s squared. So s squared divided by x give me x. So you write that x up there. Use these two now to multiply. X times s squared give me s squared, plus 1 times s give me plus x. Then you do subtraction again. When you subtract, this cancel out, this one become minus, so this one become minus 5x minus x give us minus 6x. So you bring the next term down, that's minus 6. Start the process again. Use this one to divide minus 6x. Minus 6x divided by x will give you minus 6. Write this minus 6 here. So now use these two to multiply this minus 6. X times minus 6 will give me minus 6x, plus 1 times minus 6 give me minus 6. Then you do subtraction. When you subtract, this minus cancel all this minus, making them positive. When you add it together, you have a remainder 0, 0. So that means this linear function is a factor of this polynomial, and this quadratic function is also a factor of this polynomial. Since this polynomial must have 3 factors, we must factorize this quadratic function. So I bring this quadratic function down now. That is s squared plus x minus 6. Think of two numbers you multiply to give you minus 6, and you add them to give you plus 1. Let me pick plus 3 and minus 2. Plus times minus minus 3 times 2 6 satisfied. Then for addition, plus 3 minus 2 give me 1. So I will replace this plus x with this plus 3 and minus 2. So I'm going to write it as s squared. Instead of plus x, I'll write plus 3x. Instead of this plus x, I'll write minus 2x, then minus this 6. Now here you factorize, s is common, so you take x bracket x plus 3. Whatever you have here, quickly write it here also. Think of what you put outside this bracket. When you multiply, give you this, that's minus 2. So you can see that s plus 3 is common, so you factorize out s plus 3. So you are left with s minus 2, x minus 2. So these are the two factors of this quadratic function here. This quadratic function has the two factors. So in a nutshell, if my original polynomial function I say is f of x, I'm talking about the whole of this one, which is our dividend. Let's say it's f of x. Then I will now say f of x now, the factor now are this factor and these two other factors, making 3. So I'm going to have it as s plus 1 times x plus 3 times x minus 2. When you open this bracket, you are going to have this back. So we have been able to solve this problem. Given these two factors, we have been able to solve for the value for p and q, and then we have been able to factorize completely. I'm most grateful for having your time. Please do not forget to like, share, subscribe. Click on the notification button to have more of my video. Thank you so much for your engagement. Bye. Have a nice day.